Now note that the square of any number is always positive, and this is also a positive number. So therefore this condition is satisfied, because this will give a positive number, positive, this will give a positive number, positive number is a positive number only, which is not equals to 0 and greater than 0. So the condition is already satisfied. So the domain of x, the domain of the function is all real numbers only, because if you put any value of x, even if you put minus 10 plus half will give you minus 9.5, but minus 9.5 whole square will give you a positive number, and plus this is also a positive number, so which therefore it will be a positive number which is not 0. So therefore you can take any values of x, because the condition will be satisfied either way, since there is a square here. The domain is R. Now let's move on to the next function, which is fx equals to log 5 minus 6x. So for a log quantity to be real, this number must always be greater than 0. 5 minus 6 must always be greater than 0. So therefore 5 is greater than 6x, which can be rewritten as 6x is less than 5 and x is less than 5 by 6. X is less than 5 by 6 means that we cannot exceed 5 by 6 or cannot be equal to 5 by 6. So therefore x belongs to any number lesser than 5 by 6, so therefore it can go to minus also. So the answer is minus infinity 5 by 6. And note that I have given the first bracket here because we are not considering the value of 5 by 6. We are not taking 5 by 6 as a part of the answer. That is why first bracket. Now let's move on to range. Range of a function is basically the output. Domain is what the input, the set of values we can substitute x with. That is why it is domain is the input value. We can the values we can put in place of x in the function, that is domain. And range is the set of values that we will obtain after such input. So for calculating range, we must use this method that let y equals to whatever the expression is. So let's use the same examples only. Fx equals to x plus 4. So let y equals to x plus 4. Y minus 4 is equal to x. But since x is a real number, therefore y minus 4 is also a real number because of this equation. And since y minus 4 is a real number, then y is also a real number if you remove 4. The second function is one by 4 x square. So let y equals to 1 4 minus x square. Four minus x square is 1 by y, alternating it. We are rewriting this expression in terms of x square. Why, I will tell you later. we are trying to make one side just x square and shifting all the other values to the other side of the equals to sign. So 4 minus x square 1 by y minus 4, and then if we change the sign, then it is 4 minus 1 by y, which is 4y minus 1 by y. Now it is, as stated earlier, the square of any number is always greater than or equal to 0. So therefore x square must be greater than or equal to 0. And from this equation we can understand that 4y minus 1 divided by y must be greater than or equal to 0. So suppose for a fraction to be positive, either both numerator and denominator both have to be positive or both have to be negative. For suppose the fraction is 3 by 4, here both the numerator and the denominator are positive, and note the fraction minus 3 by minus 4, the minus minus gets cancelled off, so therefore this is a positive quantity. So for to obtain a positive number, either both the numerator and denominator both have to be positive or both have to be negative. So if the same case applies here, either 4y minus 1 is greater than 0 and y is greater than 0, or 4y minus 1 is lesser than equal to 0 and y is lesser than 0. Now if we solve for y from this inequality, we can get that y is greater than equal to 1 by 4, and 1 by 4 is already greater than 0, so therefore we don't need to bother much about this inequality. 1 by 4 is already greater than 0. We just have to focus that we just have to know that y is greater than or equal to 1 by 4. And in this case, if we solve here, then y comes as y is lesser than or equal to 1 by 4 and y is lesser than 0. Since the 1 by 4, let me just show you, let me just draw you a graph. 1 by 4, 0. There are two inequalities here. The set of values, set of answers for this inequality, y is lesser than equal to 1 by 4, will be all the numbers from this side, and for the set of values satisfying this inequality, the set of values will be from this side. Therefore we will take the answer which is common to both inequalities. Therefore this part which is starting from 0 and satisfies both inequalities, so therefore y must be lesser than 0. That is our answer. So the whole range is basically RF equals to minus infinity 0 union 1 by 4 infinity, third bracket, because in the 1 by 4 is included in the answer, and the union because there are two sets of answers and we have to take both, so therefore we are using the union sign. I hope you understood that. Now what was the third function is fx equals to root over 4 minus x square. So let y equals to 4 minus x square, sorry, root over 4 minus x square. Squaring both sides, we get 4 minus x square. If we move x to this side and y to that side, then x equals to 4 minus y square. Now as we know, x square can be either greater than or equal to, wait, no, sorry, my bad. Here we must have seen that this is a real function, so therefore 4 minus x square is lesser than or equal to 0. So that means 4 is greater than x square or x square is lesser than 4. Here that means that x square is greater than 0 and x square is lesser than 4, lesser than equal to 4. So there are two inequalities with the same with a common variable. We can rewrite this as 0 less than or x square, which is these are the sets of values. Now x square is 4 minus y square. If we minus 4 from all sides, then we will get minus 4 minus 4 is 0. Now we need to change the sign, we need to turn it positive. So if we do it positive, then we'll change the sign here. Therefore y can either be lies between 0 and 4, and third bracket, because 0 and 4 are included in the answer, because the condition is either greater than or 0 or equal to 0. Sorry, my bad. Note that in this expression we considered the main expression also. We did not just simplify and then go on about the x square lesser than, say, greater than equal to 0. We did not just do that. We have to be observant. We have to find out another characteristic of x square. Another characteristic of x square was here only, that 4 minus x square will be greater than equal to 0, and so from here we got to know that x square is lesser than equal to 4. So we do not just rely on this one characteristic. We have to find all characteristics of x square when we are finding when we are calculating range. For that you have to be very observant about the question.